Today's lesson is going to be an introduction to solving quadratic equations. And the way we're going to do it today is by taking the square root. To kind of help visualize what we're going to be doing, let's start by graphing this equation by plotting these points. So I have my points plotted now. And when we solved systems of linear equations, we were looking at where the two lines intersected, if they intersected at all. We can kind of think the same way when solving quadratic equations. So if we had this equation, 2x squared minus 6 equals 2, okay, remember that if I wanted to graph the line y equals 2, we go up 2 on the y-axis, and we draw a horizontal line. So you could see that this has two different solutions. We have two different intersection points to this equation here that I have in green. So two intersection points means we have two solutions. Well, what about if I said y equals negative 6? Okay, negative 6 is down here in the y-axis, and we only intersect one time. Right? What if I said y equals negative 10? Okay, well, 6, 7, 8, 9, 10. So we could have two solutions, these two intersection points. We could have one solution, or we could have no solution. It all depends on what the right side is equal to, what the problem gives us. So just like when we're solving linear equations, we have one solution. When we solve quadratic equations, we could have one solution, two solutions, or no solutions. So how many times could a line intersect a parabola? Well, it could intersect 0 times, 1 time, or 2 times. So we have to take all that into account when we solve quadratic equations. Let's talk about function notation. And this is a little bit of a refresher from Algebra 1. F of x really just means y equals. And if we see something like f of 3, what this means is that we're going to plug in 3 for all x's that you see. Now, if we see f of x equals 3, what this means is you're going to set the equation equal to 3. So you can also think about it as saying y equals 3, what does x equal? That's another way to go about it. So just like the graph we had above, it says solve f of x equals 2x squared minus 6 when f of x equals 2. So what this part is telling you, that means to set the equation equal to 2. So 2x squared minus 6 equals 2. So we're going to try to get x by itself. We're going to add 6 to both sides. We get 2x equals 8. Divide both sides by 2. We get x squared equals 4. So to undo this x squared part on the left side, you need to take the square root. So we're going to take the square root of both sides. When you take the square root, you have to think about two solutions. So if you go in the calculator and you type in the square root of 4, you're going to get 2. So you can say x equals 2. However, when you think about plugging this back in, you have to realize that x squared equals 4 means that x could be two different numbers. It could be positive 2, it could also be negative 2. Because if we look at our calculator, negative 2 squared is positive 4. And if we go back to our original function, 2 and then times negative 2 squared minus 6, we get 2 like the original equation I have in light blue is written out as. So we actually have two solutions. So we write this as x equals plus or minus 2. And you could say x equals negative 2 and x equals 2. So you need both solutions in order for the question to be correct. So something I always stress out to students is that when you are solving an equation and you have to take the square root in order to get x by itself. So you're going through, you solve this equation, and to solve it, you have to take the square root. You need to use plus or minus. So when you take the square root, you must use plus or minus and get two answers. Okay, now there could be equations that already have square roots in them, and then you don't need to worry about plus or minus because the square root's already there. But when we solve this equation right here in yellow, we had to take the square root, so then we have to have plus or minus. That accounts for the two solutions. You know, up here, you saw that we could have two solutions here. All right, let's look at example number 2. So we have this equation here. 2 times x minus 4 squared plus 1 equals 288. Let's subtract 1 from both sides. That gives us 2 times x minus 4 squared equals 2. Whoops, this should be a 9. So then we get 288. And then we divide everything by 2. We get x minus 4 squared equals 144. Okay, so then we take the square root of both sides. All the square root does is get rid of the squared part. So we have x minus 4 equals, well, you would think the square root of 144 is 12, but because we took the square root to solve this, we have to do plus or minus 12. Well, now you'd be thinking, well, what do we do now? We have x minus 4 equals plus or minus 12. This becomes two separate equations. So we have x minus 4 equals negative 12 and x minus 4 equals positive 12. So we solve both of these separately. We get x equals negative 8 and x equals 16. So these are the two solutions we have. So like in example number 1 over here, where it was just plus or minus 2, don't think that it's always going to be that number, plus 2 and minus 2. Here the answer was not plus 12 or minus 12. We had to deal with this minus 4 here. And once we dealt with that minus 4, we got x equals negative 8 and x equals 16. You can always double check your answer by going to the original equation. And I'll just do it for one of them so you can see. So I'm going to do 2 parentheses x, so negative 8 minus 4 squared plus 1. And I hope we get 289. And we do. So I know that we did this correctly. All right, let's look at the next page. So example number 3. What we're going to do is we're going to take negative 7 and set this equation equal to that. So x squared over 5 minus 12 equals negative 7. So we're going to add 12 to both sides. we get x squared over 5 equals 5. Multiply both sides by 5. And we get x squared equals 25. So we just have x squared by itself. So we can take the square root of both sides. That gets rid of the square root, and we get x equals plus or minus 5. And that is our answer. Then example number 4, when it says, what are the zeros? Okay, that means set that equal to 0. This means that y equals 0. Another term for that is your x-intercepts. So we're going to set this equal to 0. X plus 5 squared minus 81 equals 0. So plus 81 to both sides. Then we have x plus 5 squared equals 81. And when we take the square root, because we have this x plus 5 in parentheses, that's going to stay with us. So it's going to be x plus 5 equals plus or minus 9. So now we have to have our two separate equations here, where x plus 5 equals negative 9 and x plus 5 equals positive 9. Subtract 5 from both sides, x equals negative 14. And in the second one, subtract 5 from both sides, and x equals positive 4. So these are the two solutions. Okay. So what I want you to do is I want you to try examples numbers 5 and 6 and see what you get. So pause the video and try it, and once you're done, unpause it and we'll talk about it. Okay, so for example 5, this is what you should have gotten. You set that x plus 6 squared equal to 100. And then once you take the square root, you have x equals plus or minus 10. You make your two equations, and you get x equals 4 and x equals negative 16. Now, I was a little bit mean to you guys on example number 6 because you went through, you did the correct steps, and then your calculator gave you an error. Well, remember, you can't take the square root of a negative number. So when we get x minus 3 squared equals negative 25, that means there's no solution. Now remember, all the way up here, this purple line, that means there'd be no solution to that equation if it equaled, up in this instance, negative 10. So there's no solution to this. We can't take the square root of a negative number. We might be learning that later on and what we can do when we run in that situation. The last problem we're going to talk about is word problems. So we have an object that is dropped. Its height is in feet is given by h, and t is your time in seconds. And here's a function. H of t equals h, this little 0 means h naught, minus 16t squared, where h naught is the initial height of the object. Okay. So this model assumes that air resistance and all that is not affecting it. So if you drop an object off the roof of an apartment building that is 240 feet tall, so that's your initial height. So this tells us that h naught is 240. How long will it take to hit the ground? So we need to solve this and figure out what t is. Now the height at the ground, when we say how long will it take to hit the ground, that means h of t is 0. So we're going to set up our equation as 0 equals 240 minus 16t squared. And then we'll solve this by adding 16t squared to both sides. So we get 16t squared equals 240. We'll divide both sides by 16. We get 15 equals t squared. And then we take the square root, we'll get t equals plus or minus 3.87. Well, you need to think about this problem. What does t represent here? T is representing time. Is it possible to have negative time? Does it make sense to say, oh, the ball landed or this object landed 3.8 seconds ago, in the past? No, that doesn't make sense. So you need to specify that t is only equal to 3.87 seconds. So that only applies really to word problems where you have to think and determine if the answer makes sense. All right. So this was just a brief introduction of solving quadratic equations by taking the square root. I hope that this wasn't too difficult and that you were able to understand and be able to ask me questions later on. So make sure you hit the like button and subscribe.